Good afternoon. My name is Norberto Valdivieso Godina, and I am going to talk about this project named Cobalt Oxide Nanoparticles supported on three-dimensional order nitrogen-doped carbon materials for efficient oxygen reduction and evolution reactions in metal-air batteries. These batteries have emerged as a promising alternative for efficient energy storage devices, and using defect engineering strategies such as doping carbon structure with heteroatoms like nitrogen can improve the general performance of these batteries. Because of this, in this work, a bifunctional electrocatalyst based on cobalt oxide nanoparticles supported on a nitrogen-doped three-dimensional ordered microporous carbon material is proposed. In order to achieve this, three steps of synthesis and characterization were carried out. In the first step, a pristine carbonaceous material was obtained using glucose as a precursor. Then, this material was doped with nitrogen using urea as a doping agent. And finally, this was dispersed in ethanol with cobalt acetate, and a isothermal treatment was performed. Figure 1 shows an XPS spectrum of the carbon 1s and nitrogen 1s of the nitrogen-doped tridome carbon material. It can be noticed the presence of pyridinic nitrogen, which can be related to an electrochemical activity, demonstrating that the doping process was successful. Figure 2 shows XRD patterns of pristine tridome carbon, nitrogen-doped tridome carbon, and a spinel-like cobalt oxide supported on a doped tridome carbon. Signals of a cubic spinel-like cobalt oxide can be observed. Also, this information can be confirmed by a selected area electron diffraction pattern shown in Figure 3D. Figure 3 shows as well the tridome morphology and the presence of the cobalt oxide nanoparticles. Finally, in Figure 4a, we can observe a set of oxygen reduction reaction linear scan voltammograms at different angular speeds. And in the inset, a Kuteki-Levick study demonstrates that the material catalyzes this reaction through a 4-electron pathway. Figure 4b shows an oxygen reduction reaction linear scan voltammograms comparison at 1,600 RPM. It can be noticed that both nitrogen-doped tridome carbon and the spinel-like oxide supported on it improve the kinetics of this reaction compared to the pristine tridome carbon, due to this later presents a mixed 2 and 4 electron pathways, and these doped materials only have a 4 electron reaction pathway. Not only this, but also they have a better half-wave potential and smaller overpotentials than the pristine material and the spinel-like oxide supported on carbon vulcan, being comparable with the platinum over carbon reference. On the other hand, Figure 4c shows that the best material for oxygen evolution reaction is nitrogen-doped tridome carbon. For these reasons, we can say as a conclusion that a carbonaceous material with tridome morphology and doped with nitrogen was obtained using a relatively simple synthesis route. As well, it was possible to synthesize a spinel-like cobalt oxide employing nitrogen-doped tridome carbon as a support. Both of them exhibited an electrocatalytic activity in oxygen reduction and evolution reactions, following a 4-electron pathway, which placed them as a viable alternative to be used as a cathode material in metal air batteries. Thanks for your attention.